Write an equation given a graph. The problems? So I will do them later if we have time. If not, I'll send it to you guys on Remind. Okay, page 15. Okay, so we're going to write an equation for this graph. Now, if you look at this graph, what kind of graph does it look like? Tangent, right? Okay, so it's a tangent graph because it goes up to the right. And also, what makes it a tangent graph is actually it starts at 0. So this is an important point because we're going to talk about another graph later on that looks just like tangent, but it's not tangent. So you have to know where tangent starts. All right, let's look at it. So tangent graphs are, or tangent equation is always A tangent B theta or x, it doesn't really matter. So what we want to do is figure out A, figure out B. All right, which one do you guys want to do first? Both of them have some difficulty. Huh? Figure out A or B. A? Okay. How do you figure out A? Well, let's first figure out where the asymptotes are. Where do you guys think the asymptotes are going to be? 0. Luke coming out with it. Yeah. Pi. Okay, good. So these are where the asymptotes are. We know that halfway between the asymptote is where the tangent line will start. And then halfway between that is where we're going to go up to the amplitude and go down to the amplitude, right? So then what you want to do is just look straight up and say, where does it hit on that point? And then you can go straight down and say, where do you hit on that point? So what is that number that this amplitude is hitting? 1. Luke is slowly redeeming himself. Okay, so A is 1. The next thing you want to do is figure out B. Okay, B has to do with period. Okay, so hopefully this will clear things up a little bit. What is the period of this tangent? So how long does it take for one cycle to finish? So 2 pi over 3. 2 pi over 3. All right, this is a little bit tricky. 2 pi over 3 is equal to, what is the period formula for tangent? Pi over b. Okay, so please don't set it to 2 pi over b. We only use 2 pi over b to graph the cosine. Okay, we only use 2 pi over b to graph the cosine to figure out where the asymptotes are. And what you can do is kind of look at it. This is, so if you had a cosine graph, within each cosine graph, you can see that there are 2 tangents, right? So there should be another one here. So 1 tangent, 2 half tangents makes up 2. So basically, every cosine has 2 tangent, making tangent half of the period of cosine. Okay, all right, no head nods. You guys are confused. All right, so anyways, if you look at a tangent graph and you're trying to figure out the period, period is going to be however long it takes to repeat itself. But you want to set it to the tangent period, not the cosine period or the sine period. So pi over b. Okay, so now what we want to do is cross multiply and solve. 2 pi b equals 3 pi. Okay, divide both sides by 2 pi. Not sure if you can do it in your head, but 3 pi divided by 2 pi is 3 over 2. Okay, the last thing you want to do is just double check, is there some reflection involved, just so that you write the correct equation. This graph is still increasing, so we're good. It's a normal tangent graph. So this equation is going to be y equals tangent 3 over 2x. Okay, because this is just a normal tangent graph. If it starts to decrease, then you'll put a negative in the front. Are you guys okay? Yeah.
So you don't use, it's called theta, right?
You can use theta if you want. You can write it as y equals tangent 3 over 2 theta if you want. It's the same.
Same thing. Okay.
Yeah. All right, let's try one. Ooh, this one flipped over. All right, let's have you guys try one. So you gotta figure out A. So what is the amplitude, the period, and then B. Okay, so some of you were a little bit stuck on A, which is understandable. It is a little tricky. Halfway between the asymptote is the starting point. Halfway between the starting point and the asymptote is where you want to look at. So this is going to be 1. Okay, so A is 1. Next, the period itself is 4 pi. So that is equal to pi over B. Okay, cross multiply. B is 1/4. Okay, and the last thing you want to do is look at your tangent and say, does this look like a regular one? It doesn't. It looks decreasing instead of increasing, so there's a negative involved. So the final answer is y equals negative tangent 1/4x, or 1/4 theta. Okay. Let's see if we have time to do one more. I think. Do you guys want to try one more? Sure. Okay, last one. So this is y equals 0.5 tangent 2x. Good? Okay, let's move on to the next one. We are now ready to move them around. So this is a little bit tricky because you really need to be paying a lot of attention to how you're going to move it around so you don't make mistakes. All right. We've been talking about translation all year, right? Transformations. So it's the same thing. We're coming back to it. So what does A mean? Stretch and compress. Stretch and compress. And in this chapter, it also means amplitude, right? All right, what does H do? Left, right. Okay, so H means we're going to go left and right, but we're in trigonometric graphs. We actually have a new name for this. This is called a phase shift. So we don't quite, it is going left and right, but we just call it a phase shift. So we'll say like, oh, this is a phase shift of pi over 2. And then we can say if it goes left or right. Okay, K does what? Up and down. And then that is the vertical shift. Okay, we're going to skip over this practice part because it's very easy. It's all review. So let's go on to actually graphing it. Okay, we are going to start with the easy one. So let's go down to practice number 1. Sine x plus 3. First, let's identify the parent function. What's the parent function? Sine x, very good. Now, what is the transformation? Up 3, right? Okay, how do you know if it's not left 3? Yes, not in the parentheses. If you see something like this, you would go left 3. Because it has no parentheses, it's actually up 3. So this is like the function that's stuck together. If you have this, then this is the function. Okay? So the parentheses makes a big difference. All right, so we are going to move the sine graph up 3. let's graph it. So this is a normal sine graph, but we're gonna move it up 3. So here's my trick in doing all this stuff. Because we're gonna move it up 3, so what we're gonna do is we are going to create new origin where the transformation happened. So it's moved up 3. So what we're gonna do is draw a new axis there. And we're gonna think that is the new x and y. If you don't do it this way, it will be very hard to graph. So whatever transformation it says, you're gonna move your axis there. And then from there, you're gonna graph your sine graph. You already did the 3, the plus 3. Now, so you already took care of this part by moving it up. Now you're just gonna graph sine x, okay? Someone's phone or iPad, make sure you silence it. Okay, so we're gonna graph the normal sine graph now on top of the red axis. So this is amplitude of 1, b is 1, so period is 2 pi. All right, so we're just gonna graph a regular one, so this is 2 pi. Half of a period, half of that. How much do they want us to graph? It doesn't, oh, it says to graph, so the direction says graph the interval to 2 pi. So I am in 2 pi, so I'm good. I just had to graph that much. The amplitude is 1. This is a little bit tricky. It goes up 1, down 1, okay? Up 1, down 1. So you're gonna start here. Goes up, down, down, up. So this is the sine graph moved up 3. Are you guys good? Okay, let me ask you a tricky question. Not really tricky, kind of a thinking question. What's the range on this graph? What's the range? What's the possible y value? 2 to 4. 2 to 4. We're starting at 2, goes up to 4. Not -1 and 1. That's if we start at 0, but we shifted everything up 3, right? The blue is still the real one. The red is to help us graph it easier. But the red one is not the real axis, okay? The blue one is the correct axis, so this is still 0. The origin is, on the blue is still 0. Goes 1, 2, 3, 4. So then this graph is moving between 2 and 4. Okay? All right, let's try another easy one. This one. Okay, so the parent function is sine. What is the transformation? Right, pi over 2. All right, so let's go ahead and, this is my normal axis. Since we're gonna move left and right, we need to put some axis points or label down so we can move it correctly. Okay, I'm gonna move it right pi over 2. So I'm going to use a different color and move my axis to the right. Okay, from this new red axis, I am going to graph sine. So this red origin is now my origin to help us graph. What is the period on this sine graph? Oops, sorry. 2 pi. So from here, I am going to count 2 pi. Do I stop at this 2 pi? No, I have to go how much more? Pi over 2. Are you guys all okay? Yeah? Okay, so we're going to have to go pi over 2 more. That's the 2 pi that after I move. Okay, so from here, this is 5 pi over 2. Okay, so half of that again, and then this goes up 1, down 1. And then I'm going to start at 0, up, down, down, up. Yep. 5 pi over 2, so 2 pi plus pi over 2. That's 4 pi over 2 plus pi over 2. That's 5 pi over 2. So basically I added another pi over 2.
Why do you have to do that?
Okay, so you can see that this is, the red one is my new origin, right? It moved over pi over 2. So from here, I need a whole period of 2 pi.
Oh,
But this old 2 pi is not enough, right? Okay, so far? Okay, let's add on a little bit. We have 2. Actually, this one only has 1 translation. The period is just a little different, and it's a cosine. Okay, what do I need to do to move the transformation? What's the transformation on this? Down 2. Okay, so I am gonna move my axis down. Do you guys think you can do this without my help? Yeah? Try? Okay, so we are gonna graph a cosine. You are gonna graph within 2 pi. This one's a little tricky because the period is going to be really long, but you only want to see between 0 and 2 pi. So you might only graph half of the period instead of the entire period. Okay, try it. Okay, so this period is 4 pi. If you're not really good at drawing half of a period because up to 2 pi is only half of the period, then what you can do is, draw more all the way to 4 pi, but the part that's shown is only up to 2 pi. Okay, so this is -1, this is -2, -3, just so that we know where the real numbers are. This is a cosine, so it's gonna start from here, goes down here, and then if you have more points, it would go back here and back here. But up to 2 pi, you will only see that much. Okay? All right, we are ready to add more than one thing together. Huh? Yeah?
Why did you go like 2 steps? Because you did like 2 pi.
The period is 4 pi, right? Yeah, so then halfway is here, halfway is there. So then technically it should go down, down, up, up. But then we only saw half of the graph up to 2 pi. Yeah.
Why is the period 4 pi?
Why is the period 4 pi? This is b, right? So 2 pi over b is 4 pi.
Oh, shoot.
All right, let us add on. Let's do, there's no easy one here. They're all pretty hard. Okay, we're just gonna do it. Huh? All right, let's look at this one. Ooh, a lot of things going on. What's the first transformation? Right pi over 3. And then what?
And then reflect.
Oh,
I'm looking at the
no. There's no stretch. Huh?
Down 3 over 2.
Down 3 over 2. This is the question that's a little bit higher. Like, we were doing the practice problem. This was in the middle of that same page. Sorry. It's the same problem on the next page too.
What do you do with the 2?
2 is the period.
Wait, where is it?
Sorry, 2 is B. Sorry. This is still on page 18 in the middle part.
We're at a really similar.
Yeah, the next page has the exactly same equation. Huh? Why, you guys are all anticipating the horror this may come. Okay, so what's a on this one?
2. No, 1.
1. B is 2. So then period is pi. All right. H is pi over 3. K is negative 3 over 2. Okay, so this is it. Okay, 0 to 2 pi. Okay, this is going to be scary. Oh, this is really bad. Okay, we can do this. We can do this. Oh boy, is correct. Okay, write pi over 3. Where is pi over 3?
In front of pi.
Huh? Well, where is pi over 3?
Pi over 3?
Yeah, because we're going to move right pi over 3. Where's pi over 3? Don't know. Approximately.
Like,
Okay, is it bigger than pi over 2 or smaller than pi over 2?
smaller.
Bigger.
Wait, okay, talk to your partner. Is 1/3 smaller or bigger than 1/2?
Smaller.
Smaller. All right, right here, about here. Okay, and then we're going to go down 3 over 2. Okay, let's draw some axes. Okay, we're going to go down to 3 over 2. That is 1/2, negative 1/2. Oh, okay. All right. We said the period is 1 pi. Oh man. Okay, so from pi over 3, we're gonna count 1 pi over. Why did I do this? I will take this problem out next year. Benefiting the freshmen this year.
No, keep it. Number 2.
Make them suffer. Okay.
Is this going to be on the test? Like,
No, not this crazy. This is gonna be. Am I sure?
The last chapter.
Okay, 4 pi over 3. A little bit bigger than pi, but smaller than pi over 2. Ooh, okay, from here, we're going to graph, right here actually, we're going to graph sine. McKenna's like, what is going on with all these little lines? Okay, we moved the axis over pi over 3. The period is pi, so pi plus pi over 3 is 4 pi over 3. Halfway. And what are we graphing?
what do you add pi to? Because pi is a period, so what do you add pi?
Pi to pi over 3.
Wait, why did you get 4 pi over 3?
Pi plus pi over 3 is 4 pi over 3. Pi is 3 pi over 3. 3 pi over 3 plus pi over 3 is 4 pi over 3.
So 4 pi over 3 is your period?
No. 4 pi over 3 is the actual location, but the actual distance is still pi. On the original graph, it says 4 pi over 3, but the actual length is pi.
Wait, so you...
Okay, let me finish graphing. Okay, goes up, down, down, up.
I don't even want to do this anymore.
Okay, so this is probably one of the worst ones. That was terrible. And besides this, some of them you'll have to graph in radians, so there's no pi, just like 1 radian, 2 radian, 3 radian. It's okay, those are, just draw it as is.